Hey, this is Berg, and we think we're live. Are we live? Nope. So I think I'm live, I just don't know how to find a link. Current viewers, 0 viewers. Say something. Hi. Oh, share. Here we go. Okay, Telegram. Oh, I've been on mute this whole time. So on top here is a new block. So let's mark the time. Where might I get off mute? 12 minutes. 12 minutes in. Okay. 12 minutes in. So we have Windows on top. We have this is our Bitcoin Core running. That should on top, but that should be part of a hotkey setting. Alt Shift Q. Alt Shift W. Alt Shift Q. Apply. Okay. Now let's go back. Alt Shift Q. Alt Shift W. Okay, so on the top we have Bitcoin Core running. Now we want to do stuff with Bitcoin Core, so what we do is we PS minus EF. Type it to okay, so Bitcoin D is running like this. Bitcoin D minus configure file, bitcoin.conf, sudo Bitcoin D. That's what's running on our machine right now. Let's do top. Bitcoin D. Okay, so at the top, hold on, let me go back to Alt Shift Q. Let me see if I can actually see the shit. Yeah, it's not the best. It's not the best for me either, that's the honest truth. Let's It's not clear for me either, so why would it be clear for you guys? Such a good question. I'm not gonna mess with it. It's good enough for now. Let's try if I do Alt Shift W. Yeah. Anyway, the text is not clear. That's what happens when you try to mess with resolutions. Bitcoin D is running. That's really the only thing running here. So we'll hit Escape Q. Okay, so we got out of top. Now we want to communicate with Bitcoin D. So we want to say use Bitcoin CLI. Now we have some concerns about this. Specify a config file. Use the test chain. Get info. This is a pre-release test build. Use at your own risk and not use for mining or merchant applications. Verification progress 0.99999. That changes. What the fuck is that? Okay, so the two things that jump out to me with Bitcoin CLI is three things. One thing is that I saw some JSON communication that indicates this is more like a web interface. Second thing is, it seems like maybe Lightning uses this as the way to communicate with Bitcoin, which would mean it's more native, like maybe we do some shared memory or piping. Here you go, HTTP, so it is HTTP. Okay, so when you're communicating with Bitcoin through this thing, you lose all the native Bitcoin format and stuff. Hold on. IPv6, yeah. That's one. Second thing is, what did we just look at? Now this get info thing, right? Verification progress. What the hell does that mean? Progress bar, enable wallet. This is literally telling me how long it takes me to process a block. Verification progress. Okay, I guess it's time for Google. It's almost impossible to use this, to be honest with you. I can't read anything. It won't even give me what percentage I'm on right here. This is so stupid. Something wrong here. Resolution. If I do this, everything's gonna be screwed up. Is this any better? Okay. Back to the program. Alt Shift W. Verification progress. How to check if a blockchain is up to date using Bitcoin D. If a blockchain is up to date. God. Get block count compares it to the output. Others have said there's no absolute way of telling if your blockchain is up to date. There's no such thing as blockchain up to date. It's there's something called the finality curve. The first person that sees a new header that matches, right, the proof of work, starts broadcasting it, then you know that someone found a block. But especially in, I don't want to talk about Bitcoin Cash, but especially if you don't have majority hash rate, that means nothing. Now you have to verify that the block is legitimate, right? And if you're doing with like proof of stake and stuff, right? You don't even have that initial advantage. So let's go back to our new best. You see that? Dude, let's just start with that, okay? My God. I don't know why I'm tweaking over this question, but okay. New best, guys. New best. Update tip, Dex chain, new best. What does this mean? Hope everyone knows this, what this means. And if you don't, that's fine. Okay, new best. Height. Fuck the version. New best. Best. What is this? This is what the miners are finding, right? This is proof of work. This is Bitcoin. This is the header. What is this a header of? Who cares what the header is? Let's find the, this is the number, this matches the difficulty. This is the hash of a block at height 6,0081288. Now we want it to match, right? So the first thing you do when you get a block, okay, so back to the question. There's no absolute way of telling if a blockchain is up to date. Well, the first way of knowing if you're up to date is saying, I have not received, at this point, I have not received a new block. The first thing you do when you receive a block is you receive a block header. Now I guess you say now there's a potential block. Someone told you there's a block. The first thing you have to do is look at the block header and see if it matches the difficulty. I guess the first thing you want to do is see if this is even, well, what's the difficulty here? The difficulty is this number. Okay. Some peer, right? Where's that peer? Update tip. Where'd update tip come from? Some person, some peer of yours decided that we got a new block, 89. We're not sure who related first. Progress is 1.0. I don't know why verification progress is always fucking less than 1, but there's already a new block. But okay, so we want to know that this header matches this difficulty. So we take this header and we go from, let's say, where do we want to go from? Is this hexadecimal? No, it's base 58, right? So we go from base 58 to hex. So it's not base 58, it is, oh, it is hex. Hex. God, I don't want to do it in Linux, let's just do hex to binary. Okay, hex to binary. Not hex to binary, hexadecimal. I may be wrong. Hey, come in.
What's up?
I'm live streaming. You wanna come in? Say hi. I'll say hi.
To who?
To nobody. Nobody's watching. Yeah. You gotta get on video though.
No, I want that video.
Yeah. What's up?
Nothing.
I'll pause it. Hold on.
I just got it. Let's go.
So what am I getting at? I don't know what I'm getting at, but I'm trying to figure out this number needs to be bigger than this number, which does not seem that big. So there's something I'm missing here. This decimal is, oh, the inverse of this number, right? No. Okay, Okay, sorry. 4 byte long timestamp of the block. 4 byte long difficulty type. Block header contains a set of block data. It's an 80 byte long string. It's comprised of 4 byte long Bitcoin version number, 32 byte previous block hash, Merkle root. Update tip. New best equals here you go, there you did it. End chain work, get double, okay. Wow. Block hash 2 string. Sorry. New best equals kidding me? My backspace does. Anyway, okay. New best. Height equals. Index chain update tip. Wow. Okay, so it's the block hash. All right. The block hash has a bunch of zeros. And this number of zeros, okay, what am I getting at? I'm getting at these number of zeros. Somehow, there's gonna be code somewhere that says verify, right? I'm gonna pass in the block. I'm gonna say if block hash is greater than difficulty. So I think it may be 1 minus block hash. Let's get the exact Bitcoin block hash difficulty. We want to convert the Bitcoin block hash to difficulty. Hex to bin. Here we go. Endiness. Here we go, leading zeros. Compute the following every 2 weeks. I understand that Bitcoin mining finds string. less than. Well, there you go. So your difficulty number is, oops, again, sorry, can't read this. So your difficulty number is Genesis block header target hash. So the first Genesis block target was 1. Current block header hash target. So your difficulty number is Genesis block header hash target is 1 divided by current block header hash target. Okay, let's see if that's better. All right, we're trying to figure out how to go from the number of leading zeros to the difficulty. So if the current hash target is less than, okay, less than. So let's look at the previous hash target. Divided by 1. The number is 1 divided by 1 divided by difficulty. Yeah. Genesis block has a difficulty of 1. We define a block that was less than why is that 1? what a Bitcoin miner is really solving. We want make the blocks SHA-256 hash, and binary starts with a certain number of zeros. The more zeros, the more rare hash. Okay, so we have all these zeros, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Shit. Sixteen, 17, 18, 19 zeros. The amount of zeros is based on how difficult it is supposed to be to find a block. Okay, how do we do the calculation? This is the hash. Latest block. These are the hashes of the view valid transaction with inclusion shortened. And the hash of one special transaction you just crafted, building the next block. Hash of the previous block and the hash of the latest transaction. Now let's do mining by hand. It goes to complete the block with a nonce piece of garbage, such as the hash of the new block starts with 13 zeros. Dude, I get it. It seems like 13 zeros is the current difficulty. Great. But how does the 13 zeros equal this? Think about this. Come on, it's right in front of us. Because it's 1 divided by this. And I don't know how to read scientific notation, is that it? How to read scientific notation. Ten to the 2 means 7 times. 7 times, so it's e to the negative 55. One, so it's basically e to the negative. Okay, what is this number, dude? Okay, so e to the negative 155 is, letter e is used to mean 10 to the power of. So 10 to the negative 155, so 10 divided by 10 divided by 1. Let's just say it's 55 zeros. So it's 9.1 divided by that. So it's a really small number. Okay. Now let's take this number. So that's the number we got. What's the difficulty? This is the difficulty. Of course it's going to be smaller. So we're getting somewhere. That's just not, no luck. The hash does not start with a 0. 13 zeros, okay. So, why is there 13 zeros? Because it's big Indian. Let's go little Indian. That's the problem, right? God, nobody gives a straight answer. It's kind of sickening. Here we go. N-bits field is basically scientific notation in base 256. The example will take the one found Vicanoic developer reference, big Endian order. This is split into two parts. 0xa exponent, 24 decimal. Given the target, Mantisa followed by 21 zeros or 42 zeros in hex. Now, as the target takes up 24 bytes out of 32 bytes for a block hash, the remaining 8 bytes must be zeros in order for the hash to be less than the target, as well as the rest of the number being less than, of course. Usually leading zeros are omitted for readability, but 8 0 bytes is written as 16. So this number I'm not understanding it at all. Oh, because it's 256. N-bit. What is N-bit? Contrary to popular belief, this is what I know, this is what I believe, so my belief is not popular. Thank you very much. Contrary to popular belief, Bitcoin's proof of work is not actually based on the leading number of zeros. Of course it's not. Rather, the block hash we interpret it as a 256-bit integer must be less than the target value. The block hash we interpret as, when interpreted as a 256-bit integer, okay, so we have block hash. I mean, don't get too excited. We don't have any answers here, but we know this block hash. Step 1, get the block hash. Step 2, interpret it as a 256-bit integer. Okay, now that number will be less than the target value. Number must be less than target value. The target value is what actually determines the difficulty. Okay, so this is a separate problem we're trying to solve. Separate problem is the target value is what determines the difficulty. So here's the difficulty. And the target value is represented in a compact form in the n-bits field. Target value is the end bits, and here we go. The format can be found here. Get into that later. Blah, 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 blah. We don't care about the end bits. Basically, end bits field represents the big endian. We're not going to get into endianness yet. It's split into two parts. Blah, 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 blah. This gives you the 256 integer that's the first three most significant bytes of the target. Oh my god, everyone goes backwards. The difficulty for a target of a block can be read from the bits part of the header, of course, yes. My result would be this, the target decimal would be this. Let's start with the block header. 80 bytes, that looks like this. From the 80 bytes, the bits is actually the 72nd. Holy crap, we're already past all that. This number is a little Indian, so you have to reverse it. Okay, fine. Turns out to be this. God. I don't care about this. Well, there's no exact difficulty, we can only approximate it. Difficulty 1 target can be different for various ways to measure. Traditionally represents a hash where the leading 32 bits are 0 and the rest are 1. It's known as the pool difficulty. Bitcoin protocol represents targets as a custom floating point tied to limited precision. As a result, different coins offer approximate difficulty based on this. What's the difference between BDiff and PDiff? The highest possible target, difficulty 1, is defined as, which gives us a hex target of that. It should be noted that pooled mining often use non-truncated targets. So difficulty. Difficulty 1 target. Wow. Divided by current target. I don't have Python installed. Let's just see what they're talking about. The pdiff is this. Hexadecimal. This number. Let's see if that even makes sense. Minus this number. Yeah, I know what I'm doing is fucking insane right now, but some of us are insane. That number is way too big. Divided by, hold on. Divided by, sorry. God. Let's just do divided by. It's still too big. Highest possible difficulty 1 is defined as, what the fuck is that? Why is that 1? One D. Is this a special format of no, 1D minus 3 8 1B wow. So this difficulty is E, C. The next 3 bytes are coefficient. You plug this into the formula. Target equals. Oh my God. So if 1 minus block hash, no, it's much more complicated than that. Target. So n bits is the target, which equals that. And you could compare this to the target. So that turns into this, and then you're comparing the hash of our block, right? It's less than our target. And that means it satisfies proof of work. So you notice, which we don't have a proper calculator to do this right now, but this is less than this. You just could just look, right? Same number of zeros, right? So all that matters is this number here. So if it had, obviously, if this was a 1, you guarantee. So now, so our hash, which we're not going to, let's compare our hash to this, okay, A, right? A is greater than this difficulty, look at that. So this target, so our block that we're looking at right now would not match. Oops, hold on. Oh, because I didn't put the 0x. Our block is much stronger. Our block is much less. So this number is in fact the right number that I put in all the way at the beginning. So step 1, interpret as a 62-bit integer. 62-bit integer, right? So I believe I just go from, I mean, I may be wrong, but I think I was right. So this is our hash. We just put a 0x, and we do hexadecimal, and then this is our number. Must be less than the target value. Well, let's just take this target value here, because convert it. Now this number has to be less than that number. Now how do we check two numbers are? It's hard to do it with hex it's easy. Decimals it's harder, but we could just say, well, obviously, I mean, in decimal, this number is much smaller than the target because it's smaller, literally smaller. Now, if it had 2 zeros at the end, then you'd have to go, it's still smaller, right? If it had a 5, if it had a 6, then it would be bigger. So that's how you do it. Now, what we missed is going from the target value to this difficulty, which we get here. It's probably really easy. I don't know why there's a 0.85 though. Bitcoin difficulty started at 1. It can never go below that. For every 2016 blocks that are found, a timestamp of the blocks compared to find out how many time left. Blah, 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 blah. It only took 10 days to mean difficulty is too low. It must be increased by 40%. Difficulty can increase. Generally, difficulty would decrease. There is a bug in implementation due to the fact that calculations based on time defined it to the last 2016 blocks. Fixing quite a hard fork. Here we go. Okay. So how do we go get the difficulty? So difficulty means that I see. Difficulty that cannot be compared to the block. You have to find the target. Let's see if we could print out the difficulty. Oh, it's not giving. New best is not giving the that's coming from the CLI. See, this is what I'm talking about. Bitcoin only uses compact formats for encoding difficulty targets, which are unsigned 256 bits. All the complexities. Okay, so before we go any deeper, let's just again, get back to the program. So, the new best. This is a. So, what do you do when what we're trying to figure out is when we say get info, it says verification progress 0.9999. So we got a little hung up and what does that mean? So what we're saying is the first thing that happens is you get a new block header, and the first thing you check is that it matches the difficulty. That's exactly what SHA-256 miners are doing. They're basically taking a number, incrementing it, hashing it with the current block that they chose, and checking that it matches the difficulty. Most people say that you could just count the number of zeros at the beginning, which means that if a target that you're trying to reach less than the target, then as long as you have more zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, more zeros means that it would be less. But it doesn't necessarily mean more zeros. And in fact, in this example we found online, this is less, but it doesn't have more zeros. It has the number of zeros. So it's just like, how do you know, 9 is less than 10? 9 has 1 0, 9 is less than 1 0. It's just a quick way to do it. And it turns out that the difficulty number is a number that is not directly, I don't know the answer exactly what the difficulty number is, but it comes from the target. The target hash that you're trying to reach. And somehow the difficulty turns that number into something else. So let's do in plain English now. In plain English. It's just not going to say what we want. It's a difficulty Bitcoin number. Computationally difficult problem. Mining Bitcoin block difficult because equal than the target difficulty metric. The difficulty is the measure of how difficult it is to find a new block compared to the easiest it can ever be. Okay, the easiest it could ever be is 1 difficulty. That was the first block. The rate is recalculated every 2016 blocks to a value such that the previous 2000 blocks would have been generated in exactly 1 fortnight. 2 weeks had everyone been mining at this difficulty. This is the expected yield on average, 1 block every 10 minutes. So it'll take 2,000. Okay, what is the difficulty? God. What is Bitcoin difficulty? Okay, Bitcoin difficulty is previous 2016 blocks would have been generated in exactly 1 fortnight. So what is Bitcoin difficulty? It's a number to represent hash rate needed for the previous 216 blocks to be generated in exactly 1 fortnight. What the fuck is a fortnight? 2 weeks. Okay, now somehow this, I bet you if we say 2 weeks times So if we say 14 days times 24 hours times 60 minutes divided by 10, that would give us 2016. Let's just see if I'm right before I take credit for it. Times 24. That was 1 hour. The music shut off. 14 times 24 times 60. There it is, divided by 10. Congratulations, 2016. That's how many 10-minute increments there are in 2 weeks. So in one fortnight, there are exactly 2016 10-minute increments. So, and during that time, we want to be able to mine 2016 blocks in 2 weeks. So we look at the last 2016 blocks and we say, how long did it take us? So we actually look at the timestamps. Again, difficulty metrics. It's a measure. It's just a measure. So this difficulty is just a measure of how difficult it is compared to 1. Any blocks released by malicious miners did not meet the required difficulty target. Target is a 256 extremely large number. Blah, 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 blah. We know that. The lower the target, the more difficult it is. Okay. Wow. So, okay. So now, we have a target. And that we have a difficulty. We have a target. We have a difficulty. We have a target. Okay. Right. So, in the last previous 2016 blocks, the previous 2016 blocks would have been generated in exactly 1 fortnight in 2 weeks. I don't know how we do that. So that's for a different time. How do we estimate from the previous hashes? So if 2016 blocks took less than 2 weeks, then we want to make the difficulty higher. If it took more than 2 weeks, we want to make the difficulty lower. Okay? Okay, so I think I'm starting to get it. We add up all those numbers, and I guess so we have a target, right? If a target is 100 and we came in at 99, that's a good block. But if we came in at 50, that's we're just saying that we did 50 more times work than if we came in at 99, right? So we take all the deltas from the previous target to our actual blocks that were produced, even though it's possible that it took one test of a nonce to get a really tiny number, but the probability is, I don't know exactly, but let's just say that. So that's it. We take the previous 2016 blocks, we take the difference between what, obviously the number you got in, right? the number you got in, this number is a little smaller than this number, right? It has the same number of zeros. If it had more zeros, right? If that was, then it's a lot smaller. So the smaller it is, the higher the difficulty adjustment will be done. And now we have our answer to our question, which was, what does it mean, verification progress, and how do you start? So the first thing you do is you take the header and you check that it matches the difficulty. So that's it. So now coming all the way back to what we are trying to make a point of, which is not such a big point, but it is what it is. Our point is that the Bitcoin CLI is not, okay, it's not Bitcoin. It's not exactly Bitcoin Core. And we want to get to the bottom of exactly what the Bitcoin CLI is. We have been going for an hour, and my wife did show up, but let's just get to the music. Bitcoin CLI. There it is. Here's the CLI. CLI.cpp. Okay, we're if def 132, we're not on 132. Set up environment, set up network, try happen in AP RPC. Command line RPC. Let's just do something stupid, right? I mean, we're just doing something stupid. We're just gonna say stupid. It probably won't work. And I have no idea. There we go. So it's compiling Bitcoin CLI because we made a stupid change, right? What did we change? Let's ask Git what we changed. There we go. We said stupid. Command line RPC. April 17th. I don't like this at all. Oh, we have to do sudo install. Whatever. April 30th. Fuck, we just updated everything. Whatever. Okay. So what were we looking for? Bitcoin CLI. Get info. Stupid error. Stupid error. Cannot connect to server. Stupid error. See that? Stupid error. So now let's start Bitcoin again. And it shouldn't say stupid error, but it should say stupid error code 28, error message, loading block index. Ah, now it just says stupid version. Okay, why'd we say stupid? It's a stupid thing to say, I know. We said stupid because we're trying to figure out exactly what's happening, so we know what's happening here, right? So it's getting into command line RPC, and it is what I really want to do, which is really stupid, which we're going to do is we want to debug this. We want to make a breakpoint. Okay. So we're going to do this. So we started by saying Bitcoin. We started by saying we have a running Bitcoin D, right? You guys see it? That is weird. Oh my gosh. I don't know how much louder the music is than my voice. Okay, so we said which Bitcoin CLI, and then we said Bitcoin CLI, and we said get info. And we saw verification progress, and we don't really like what we see. We don't understand what it means. And then we realized that Bitcoin CLI is like an HTTP thing into Bitcoin. So we want to see what it's doing. We found command line RPC. We put in a print statement. So now we want to debug it. We actually want to go deeper and actually debug Bitcoin. So what we really want to do is and the reason why it doesn't matter which one we do, in a second I'll explain it. What we really want to do is just go to Bitcoin main. Bitcoin D right here. No UE connect. Return API init. Oh, look at that. Just say go to definition. And which file is this in? This is in bitcoind.cpp. AppyNet. I haven't even tried one thing. Load block thread. Can I say ls? Can I say test? Can I say anything? No. Have decal fork. Ooh, daemon runs in the background except commands. Ooh. Oh, it's only if we have decal fork. I don't know if we have decal fork. So if we run minus daemon, Bitcoin Core starting. Uh-oh. Damn it. Now I have Bitcoin D. We get in deep here sometimes. We're not afraid. Bitcoin D, Bitcoin Core, stop. Aye. Bitcoin D stop. Okay, that makes sense. So it takes in commands. I don't know how it could actually do that. How could it actually do such a thing? That would be amazing. So Bitcoin D stops. Works as RPC with no releases and somewhere in help. There's no way this is gonna work. Stop. Stupid Bitcoin Core stopping. Yeah! Stupid Bitcoin Core stopping. That's so funny. Stupid error. Alright, we're gonna change that to Dex. Okay. Damn. Alright, I didn't mean to say stupid. Well, it's already gone anyway, so I just need to recompile. Now stupid should go away. But fuck it, let's put it back in, right? Where was it? It was command line RPC, right? So stupid, we'll just say Dex. We'll just say Dex and we'll say, what's today's date? 04/30/21. Whatever, we could do it and say whatever we want because it doesn't matter. Put little trees over here, little trees over here. What's that guy's name? Bob, the painter. And now we're gonna say end L, standard end L. So okay, let's learn some C++. Standard library, whatever, C out. We want to print to the output. We're gonna print this and we're gonna add an end of line. So instead of saying stupid error, if we had an end of line, it would say stupid next line error. Here, even better, we could say. Why am I doing this? I have no idea, to be honest with you. Yeah, you just want to start editing C++ files and compiling things all the time, so you never ever have to get into a situation where, okay. So instead of stupid error, it says error, cannot connect to server, and right, that's cool. But let's just do this. We'll do another standard. Just do an extra end now. This is wrong. Error. Look at that. Still an error. Nice, our first error. 868. There we go. Okay. So now it says before our commands, it says dex 04321, and afterwards it says dex 04321, and we could, I wonder if we could stop Bitcoin CLI. Okay, so that stopped it. Oh, daemon, minus daemon, Bitcoin course starting, get info. If I could say stop, can I say start? Okay, get info error, cannot connect to server. Can I say start? No, cannot start it, if I could stop it. Interesting. Now if I don't say daemon, I wonder if I could stop it. Get info. Stop. Look at that. Tor thread interrupt. Okay, Tor. Okay, how's that different than my just doing Control C? It is the same fucking thing. I just never said Tor. Why am I using Tor? No idea why I'm using Tor. Tor control, let's see. Control spec.text. Anyway, so now we're able to, so we have Bitcoin Core running here. Actually, let's do this before we forget. We have, why are we in the .bitcoin directory? Because we have the script, right? Where's our script? It's probably in our, it's probably just gonna be work, right? Yeah, Bitcoin blocks move. Okay, what is this gonna do? Bitcoin blocks move is gonna move all our blocks from our SSD to our D drive, D Bitcoin data blocks. So date modified. Blocks. Done. Okay, now we do date modified. Oops, nothing. Didn't work. Oh, we gotta sudo it. Okay. Still didn't work. The fuck? Maybe this has to be updated or something. Oh no. Okay, that sucks. 422 is the last time we had blocks. Come on, dude. Oh yeah, well, okay. No. I don't understand. Oosh, what the fuck was that? Five 1/2021 already. Oops, root? Damn it. Why is this doing root? Is this root? April 30th, 1732. Damn it. This is confusing. Oh, loaded best. So we have to find tip, right? Dex chain update tip, right? 5-1. I don't understand. This is retarded. I may have fucked everything up. What just happened? Using obfuscation key for root Bitcoin change state. Root blocks index. There is no root. So root is just blocks April 27th. April 30th. Fuck. So all that data is in there? Config file, default data directory, no auth subpar. can't say I'm not confused. I definitely am confused. April 17th, 18th, 22nd. There should be some 30th here. April 30th. So last time when we moved all our blocks, we weren't actually, what happened was we actually downloaded the blocks. Remember once we had to restart? So it looks out, one time it ran it from our home directory, home dex .bitcoin /blocks. And the other time I ran it from root/root. So I think what's happening is, so we ran out of space and we got it to work. I think we actually are not working on the symbolic links. I don't know what's wrong with this freaking, I don't understand what happened to Explorer. Come out, Bitcoin data. Oh, is it because I do sudo? There we go. What's going on? Settings on JSON. Okay, now it's using now we're all the way back to March 9th, April 9th. So now Now we go to our blocks. It shows 430. All right, for sure, 430. And then now if we exit here, and then we run, so our, God, I don't know what happened here. Backup, no, data, Bitcoin data, blocks. Fee estimate, God, what the fuck. Anyway, forget about the fee estimate, but none of the blocks are here yet. But now when we run Bitcoin blocks move, here's anchors done. Here we go. Are you kidding me? Still not. Almost gone, Charlie.
What? Dad. What do you have to pull? Dad, open this. Open the
Dude, I'm on video, man.
Open this now.
Dude.
What? Help! Are you live?
Yeah, I'm live. I'm just
no.
coding live.
No.
Then don't. What's going on out there? Yeah, I'll shut down in a second. Right, we got to get to the bottom of why we have two Bitcoin historical blocks running, and then we're going to try to debug either Bitcoin CLI or Bitcoin D. Until next time, ladies.